The video will teach you how to add and subtract SURDS. By the end of the video, you'll have the confidence and the skills to answer GCSE questions like these on the board. I'll be multiplying and simplifying SURDS during the video, so make sure you know how to do this by watching my video on multiplying, dividing and simplifying SURDS. I'll teach you how to do questions by working through examples and explaining each step. There will be a further set of questions at the end of the video, with full written answers for extra practice. We won't be using our calculators, as most SURDS questions appear on your non-calculator paper. We'll be using one of the laws, or rules of SURDS when we simplify, so this is a reminder in case you need it. When we add and subtract SURDS, it is a little like collecting like terms in algebra. Look at the example on the board. 4 root 5, plus 2 root 5. We can add these together to give 6 root 5, because this is 4 lots of root 5, plus 2 lots of root 5 and this makes 6 root 5. You can't add or subtract different SURDS. For example, we can't simplify the next example on the board, root 7 plus root 10. We will begin by working through these examples. The questions may be different in style, but the technique to answer them will be the same. We can't immediately add and subtract the SURDS in these examples, as they are not the same. We can, however, simplify most of the SURDS. As we work through the examples, you will notice that in all cases, we first simplify any of the SURDS in the calculation that require it. We will simplify as far as possible by looking for the highest square factor. This will ensure that all the SURDS in the calculation will then be the same, enabling them to be added or subtracted. If you'd like to learn how to use prime factorization instead, to simplify as far as possible, watch my video on multiplying and simplifying SURDS. Question 1 asks us to simplify fully, root 40 plus root 90. This is a nice straightforward question, and although the roots are different, they are easy to simplify fully by finding their highest square factors. Let's look at root 40 first. The highest square factor of 40 is 4. So, root 40 becomes the root of 4 times 10, which is root 4 times root 10. Root 4 is 2, so root 40 simplifies to 2 root 10. Looking at root 90, the highest square factor of 90 is 9. So, root 90 becomes the root of 9 times 10, which is root 9 times root 10. The root of 9 is 3, so root 90 simplifies to 3 root 10. Now we've simplified both roots, we replace root 40 with 2 root 10, and root 90 with 3 root 10 in our calculation. We now have 2 root 10, plus 3 root 10. 2 plus 3 is 5, so our final answer is 5 root 10. Question 2 asks us to simplify fully, root 12 minus root 3. This is also a straightforward question. Root 3 cannot be simplified, but we need to simplify fully, the root of 12 to enable us to perform the calculation. The highest square factor of 12 is 4. So, root 12 becomes the root of 4 times 3, which is root 4 times root 3. Root 4 is 2, so root 12 simplifies to 2 root 3. Replace root 12 in the calculation with 2 root 3, and we have 2 root 3, minus root 3. This is 2 lots of root 3, minus 1 lot of root 3. So, the answer is simply 1 lot of root 3, i.e. root 3. Question 3 is a more complex question as it asks for the answer in the form, a, root 6. Don't worry if you are faced with a question like this, as we can use the answer to help us find the highest square factor of the roots. We know that both roots are the product of their highest square factor and 6, because they must both simplify to an integer times root 6. 24 divided by 6 is 4, so 4 is the highest square factor of 24. To divide 150 by 6 without a calculator, first divide it by 2, which gives 75, then divide 75 by 3 which gives 25. 25 is the highest square factor of 150. So, root 24 becomes the root of 4 times 6, which is root 4 times root 6. Root 4 is 2, so root 24 simplifies to 2 root 6. The root of 150 becomes the root of 25 times 6, which is root 25 times root 6. Root 25 is 5, so root 150 simplifies to 5 root 6. Replace root 24 in the calculation with 2 root 6, and root 150 with 5 root 6. 2 root 6 plus 5 root 6 is 7 root 6. Our final answer of 7 root 6 is in the correct form, as given in the question. Question 4 is another more complex question as it asks for the answer in the form a root a. This time we can't use the answer to help us find the highest square factor of the roots, because we don't have the value of the number under the square root in the answer. However, if you simplify both roots as far as possible, you will find that your answer will be in the correct form. The highest square factor of 700 is 100. Root 700 becomes root 100 times 7, which is root 100 times root 7. Root 100 is 10, so root 700 simplifies as far as possible to 10 root 7. The highest square factor of 63 is 9. Root 63 becomes root 9 times 7, which is root 9 times root 7. Root 9 is 3, so root 63 simplifies as far as possible to 3 root 7. Replace root 700 in the calculation with 10 root 7, and root 63 with 3 root 7. 10 root 7, minus 3 root 7, is 7 root 7. We have a final answer in the correct form, where a is 7. Take a moment to look at the solutions to these first 4 questions. The technique we used in each case was to simplify all the SURDS as far as possible, which meant we were then adding or subtracting the same square roots, enabling us to do the calculations. We will now do the following 4, more challenging questions. Question 5 is root 20 plus 3 root 45. First, simplify fully both of the roots. The highest square factor of 20 is 4. Root 20 becomes root 4 times 5, which is root 4 times root 5. The root of 4 is 2, so root 20 simplifies fully to 2 root 5. The highest square factor of 45 is 9. Replace 45 by 9 times 5, and root 45 becomes the root of 9 times 5, which is root 9 times root 5. Root 9 is 3, so root 45 simplifies fully to 3 root 5. Replace root 20 with 2 root 5, and root 45 with 3 root 5 in the calculation. Multiply out the bracket, 3 times 3 gives 9, and we have 2 root 5, plus 9 root 5. The final answer is 11 root 5. Question 6 is 5 root 27, minus 4 root 12. Like question 5, we need to first simplify the roots so they are the same, then substitute them into the calculation and multiply out the brackets and finally, subtract the roots. The highest square factor of 27 is 9. Replace root 27 with the root of 9 times 3, which is root 9 times root 3. Root 9 is 3, so root 27 simplifies to 3 root 3. The highest square factor of 12 is 4, so root 12 becomes the root of 4 times 3, which is root 4 times root 3. Root 4 is 2, so root 12 simplifies to 2 root 3. Replace root 27 with 3 root 3, and root 12 with 2 root 3 in the calculation. Multiply out the brackets, 5 times 3 is 15, and 4 times 2 is 8, so we have 15 root 3, minus 8 root 3. 15 minus 8 is 7, giving us a final answer of 7 root 3. Question 7 looks quite complex, but you will see that when we simplify all the roots fully, they simplify to an integer times root 2, enabling us to add and subtract them. Let's start with the root of 32. 32 is 16 times 2, so root 32 is root 16 times 2, which is root 16 times root 2. Root 16 is 4, so the root of 32 simplifies as far as possible to 4 root 2. Root 18 is root 9 times 2, which is root 9 times root 2. Root 9 is 3, so root 18 simplifies fully to 3 root 2. Root 50 is root 25 times 2, which is root 25 times root 2. Root 25 is 5, so root 50 simplifies fully to 5 root 2. Replace all the roots in the calculation. Multiply out the bracket, 3 times 4 is 12. We now have 12 root 2, minus 3 root 2, plus 5 root 2. 12, minus 3, plus 5, is 14, giving us a final answer of 14 root 2. Question 8, is express root 125, minus root 45, in the form x root 10, where x is a surd. Notice, this question is in a different form, as you will usually be asked to give the answer as an integer times a surd, not a surd times a surd. We can do the calculation in the usual way, which will give an answer as an integer times a surd, then adjust the answer to the correct form. We need to simplify fully both the roots. The highest square factor of 125 is 25. Root 125 becomes root 25 times 5, which is root 25 times root 5. The root of 25 is 5, so root 125 simplifies fully to 5 root 5. Look back at question 5 to see that root 45 simplifies fully to 3 root 5. Substitute the roots into the equation, and we get 5 root 5, minus 3 root 5, giving an answer of 2 root 5. We want the answer to be in the form of a surd times root 10. We have 2 root 5. We need to times root 5 by root 2 to give root 10, so write 2 as root 2 times root 2. Our answer becomes root 2 times root 2 times root 5, which is equal to root 2 times root 10. Our answer is now in the correct form where x is root 2. Congratulations, you can now add and subtract surds. Complete these 4 extra questions for practice, before moving on to my next video on how to expand brackets. Pause the video while you do the questions, press play to reveal the answers. Thank you for watching the video. If you found the content helpful, then don't forget to hit the subscribe button, and turn on notifications to get alerts when I add new videos.